Have you ever needed to swap the values of two variables in Python? Forget about temporary variables. Python offers an elegant one-liner solution. Traditionally, swapping variables required a three-step process using a temporary variable. First, you store one value in a temporary variable. Then, you assign the second value to the first variable. Finally, you assign the temporary value to the second variable. But Python offers a much more elegant solution, a one-liner. Simply write AB equals BA. This concise syntax is the standard and most Pythonic way to swap variables. This swap syntax is widely used in real-world Python coding. Let's see how it works in an actual IDE environment. The magic behind this elegant swap lies in Python's tuple packing and unpacking features. First, the right-hand side, b, a, creates a tuple containing the values of b and a. Then the left-hand side, a, b, unpacks this tuple, assigning the first value to a and the second to b. Python always evaluates the right side before the left, ensuring original values are captured properly. Let's visualize how this swap actually works with concrete values. Initially, we have variable a with a value of 5 and variable b with a value of 10. When we execute a, b equals ba, Python first evaluates the right side. It creates a temporary tuple containing the current values of b and a, which is 10, 5. Then Python unpacks this tuple and assigns the values to the variables on the left side. The first value, 10, goes to a, and the second value, 5, goes to b. And just like that, we've swapped the values without using any temporary variables in our code. The temporary tuple is created and handled automatically by Python behind the scenes. Looking at the memory behavior, we can see that Python is simply changing what the variables point to. Before the swap, variable a points to object 21 and variable b points to object 42. After the swap, a points to 42 and b points to 21. The objects themselves don't move in memory. This behavior is consistent with Python's reference-based variable system. Variables are simply names that refer to objects in memory. The swap changes these references without needing to move or copy the actual data. The Pythonic swap method offers several advantages. It gives you clean, concise code, just one line instead of 3. There's no need for an explicit temporary variable. The code is more readable and maintainable. And it's efficient since only the references change, not the actual data. Let's see this Pythonic swap in action with a simple example. We start with two variables, a equals 5 and b equals 10. Now we execute the single line of code, a b equals ba. This single line swaps the values between the two variables. After execution, a now equals 10 and b equals 5. This elegant one-liner handles the swap efficiently without any temporary variables. You can also use this same technique to swap elements within a list. Here we have a list with 4 elements, 1, 2, 3, and 4. We want to swap the elements at indices 1 and 3, which contain the values 2 and 4. Using the same tuple unpacking syntax, we can swap these elements with a single line of code. This swaps the values at these two indices directly. After the swap, we have a new list with the elements rearranged. This demonstrates how the same swapping technique works effectively on list elements. Why does this matter? Python experts consistently favor this method for several important reasons. First, it offers exceptional conciseness. What would traditionally require 3 lines of code with a temporary variable is accomplished in just 1 line. Second, this approach significantly enhances readability and maintainability. The code clearly expresses the intent to swap values. Third, it elegantly leverages Python's tuple packing and unpacking mechanism, which is a core language feature. Finally, this pattern is considered idiomatic Python. It's the way Python programmers are expected to solve this problem. These advantages make the one-liner swap a preferred choice for Python developers at all skill levels. Let's consider the performance aspects of the Python swap technique. While some developers might worry about performance, the differences between swapping methods are generally negligible for small datasets. Python's interpreter is highly optimized for tuple packing and unpacking operations, making this approach efficient in practice. Most importantly, the Python community emphasizes that readability and maintainability typically outweigh minor performance differences. Additionally, this method eliminates the need for a temporary variable, potentially saving memory in some cases. In real-world applications, the elegant syntax and clear intent of the one-liner swap usually make it the best choice regardless of performance concerns. The AB equals B. A one-liner is more than just a convenient technique, it's a cornerstone of Pythonic coding. This pattern showcases Python's ability to handle complex operations with simple, readable syntax. It perfectly demonstrates Python's focus on developer productivity and code elegance. As of today, April 1st, 2025, it remains the standard approach, embraced by the Python community at large. This small example embodies one of Python's core philosophies. Simple is better than complex. By mastering this technique, you're not just learning a syntax trick, you're embracing the Python way of solving problems with clarity and elegance.